Surendra Kumar Saini, Assistant Professor, School of Computer and System Sciences, Jaipur National Institute. I want to welcome you all because now you are going to be part of this renowned university, so congratulations. Let's talk about the today's topic, that is logic gate. In the digital electronics, logic gate are the basic building block of any digital circuit. Okay, let's start. As such, there is no definition for logic gates, but we can consider this as logic gate are electronic circuit that operates one or more input signals to produce an output signal. Generally, the input of logic gates are binary number or the binary symbols. The binary logics are 0 and 1. We can use the variables as the input to a logic gate and another variable to a output. Okay, generally the symbol 1 is represent in binary for high logic and the symbol 0 is represent for low logic. It doesn't mean then 1 is 1 volt and 0 is 0 volt or ground. Symbol 1 represent the high logic. High logic, it may be a 1 volt, 5 volt or 12 volt. It is according to the R requirement. Or 0 volt may be represented by 0 volt. Symbol 0 may be represented by 0 volt, minus 5 volt, minus 12 volt or some other positive. Okay. Binary itself means there are two symbols, as we know, 0 and 1. Okay, let's start with the first logic gate, that is not logic gate. Students, to understand any logic gate, we need three basic things. One of them is the symbol for the logic gate, another is the truth table and the logical expression. Okay, as you can see, this is the symbol for the logic gate, not logic. Not logic has only one input and one output. And the truth table. Truth table is the relationship between input output, or we can say truth table defines the working of a particular logic gate or a particular logic circuit. The symbol of any logic gate or the Boolean expression of any logic gate is represent the relationship between input and output. As you can see, the not logic gate, the symbol for not logic gate is represented by this, and the truth table. Truth table is the working of any logic gate, so X as the input and Z represent as the output. In input section, X is a variable. You can assume another variable also. Suppose you want to assume A, B, C, P, Q, R, S, whatever you want. Okay. As input may be two possibilities because there is only one input. It means it can have only two possibilities. Either it may be a 0 or 1 because it is in binary. That's why if we have one variable, then there are two possibilities, 0 and 1. Okay. If we put 0 as input, the output will be 1, and input considered as 1, then output will be 0. It is the working of not logic gate. The Boolean expression for the logic gate is Z equals to X bar or Z equals to X prime. X bar represent in the Boolean algebra the complement. Complement means in the binary, if we have 0 complement, it is equals to 1, and if we have 1 complement, it is equals to 0. That is only. If we want to remind this logic gate, we will consider this in Hindi as not means nahi. Not represent the nahi in the Hindi. Okay, it means if we have 0 as input, 1 will be output. If we have 1 input, 0 we will have in output. Okay, just invert the logic. Okay, I think you got it. The second logic gate. The second logic gate is AND gate. AND gate, as we all know, we need to identify three things: symbol, truth table, and the logical expression. Okay, as you can see on the screen, the symbol for the AND gate, it is kind of a D shape in which we have at least two input. I am saying at least because we can have more than 2, 3, 4 or up to n number of input. It will depend on the design of the gate, how it can fabricated. Or yes, as you know, there are two inputs and one output. It means in the truth table we have two input. Two input means 2 to the power 2. 4 combination will be there in binary. X and Y are the input and Z is the output. Okay. As you can say in the first row of table, on the combination of 0 and 0, the output will be 0 because the basic functioning of logic gate and logic gate is multiplication, and we know already the multiplication of 0 with 0 is equals to 0. That's why the output is 0. The second row, the second combination is 0 and 1, where X is represented by 0 and Y is represented as 1. The multiplication of 0 and 1 is again 0, then output is again 0. In the third row, we have X is 1 and Y is equals to 0. The multiplication of these are again 0. It means for this combination, Z is again 0. In the last row, we can see that multiplication of 1 and 1, that is equals to 1, also in decimal number system as well as in binary. Okay. You can see the expression, the logical expression, which is represent the relationship between input and output. Z equals to X comma Y. As I already told you that you can assume X and Y, A and B, P and Q as the input variables. It is up to you. It is your choice. Okay. The symbol is like D shape. It have only two inputs for this time. Next time we can use more than two inputs. Okay. The expression for Boolean expression for the logic AND gate is Z equals to X comma Y, if we are considering X and Y are the two inputs and Z is output. Okay, let's move to the third logic gate. The third logic gate is OR gate. The third logic gate is OR gate. The symbol for the logic gate is little bit similar to the AND logic, but it is little bit different also. X and Y are the input we are considering. As usual, we are considering X and Y are input variable and Z is output. The combination of X and Y for the OR logic, the expression, as you can see, Z equals to X plus Y. Okay, the truth table, if we have two variable in input, it means we have four combination. Four combination are 0, 0, 0, 1, 1, 0 and 1, 1. Okay. For the first row, if X is 0, Y is 0, then Z is 0, because it is just an addition of X and Y. That's why the expression, the Boolean expression is Z equals to X plus Y. Okay, in the row 1, 0 plus 0 is 0, and in the row 2, 0 plus 1. As we know, 0 plus 1 is 1 in decimal. Okay, 1 plus 0. In the third row, 1 plus 0, that is again 1. In the fourth row, 1 plus 1 is 1. Okay, some of you, I think, some of you thinking that 1 plus 1 should be 2, or in the binary it should be 1 0. No, students. As we know, in the Boolean expression, 1 and 0 are just the representative of the logic, high logic or low logic. It is just 1 represent the only high logic. If we are adding high plus high, then the output will be high logic only. That's why here 1 plus 1 is 1, not 2 in decimal or not 1 0 in the binary. Okay, I think you got it. As I told you at the start of the class, 0 means just low logic and 1 means high logic only. So that's why high logic plus high logic is equals to high logic. That is represented by 1. Okay, that's why we are considering 1 plus 1 is equals to 1. Okay, it is the symbol for the OR gate. And the Boolean expression, z equals to x plus y. As you can see on the screen, z equals to x plus y. Till now, we have learned 3 logic gates. First of all, NOT logic gate. Second is AND logic gate. Third is OR logic gate. These 3 logic gates are called basic logic gates. Why basic? Because these are the basic building blocks of any further logic gates as well as the combination circuit or sequential circuit in digital electronics. Okay, next logic gate is NAND logic gate. NAND logic gate is not a different one. It is just a combination of 2 logic gate, NOT logic gate and AND logic gate. Okay, as you can see the symbol on the screen, NAND logic gate also have at least 2 input, or it may have 2, 3, 4, 5 up to n number of inputs, but it needs at least 2 inputs. Okay. The symbol for the NAND logic is little bit similar to the AND plus NOT combination. It is exactly the combination of a AND gate followed by the NOT gate. Okay, we are considering A and B as input, and output we can say Z or X, whatever. You can see the truth table. In the truth table, you can see we are considering X and Y are 2 input and Z as output. X and Y. If we have 2 input, it means we have 4 combinations. 2 to the power 2. 2 to the power 2 is 4. 4 combinations are as usual 0 0, 0 1, 1 0 and 1 1. Okay. If I remind you, then in the AND gate we have the output 0 0 0 and 1 finally. 1 4 input 1 into 1. Okay. It is just inverted to the AND gate. The truth table is just inverted to or complement to the AND gate. Okay. Let's see. The Boolean expression for the logic gate is X multiplied Y, that is AND gate, and the whole bar. Make a note, it is a whole bar, not X bar and Y bar. X bar or Y bar is the complement of X and Y, but this time it is X and Y and now the complement. The whole complement, it means first of all we need to ending operation and after that the complement of the output. Okay. In the first row we can say if we have 0 and 0 are the input and 0 into 0 is 0 and complement of 0 is 1. That's why the output is 1. In the second row 0 into 1. 0 into 1 is again 0 and the complement of 0 is 1. That's why output is again 1. In the next row, 1 into 0, that is again 0, and the complement of this is 1. In the last row, you can say 1 into 1. 1 into 1 is 1, and complement to this is 0. Complement to 1 is 0, as we know. In the NOT logic, we have seen this. Okay. The next logic gate is NOR logic. NOR logic have symbols like NOR logic gate have symbol like OR gate plus the combination of NOT gate. Okay, so now we can say NOR logic as we can say N plus OR. NOR means N plus OR. N represent the NOT gate and OR represent the itself OR gate. It is NOR. In the NOR, the expression will be, suppose we have two inputs A and B. First of all, we add A with B and the overall complement. As you can see, the output Z equals to X plus Y and the whole bar. Students, pay attention. It is whole bar, not individual bar. In the individual bar, you can write suppose X bar, Y bar or whatever. But it is never equal to the X plus Y whole bar. So make a note that X plus Y whole bar is not equals to X bar plus Y bar. We will see in Boolean algebra why it is not so equal, or you can verify with the truth table of these two components. Okay, and this is the truth table. As you know, it will be the complement of the OR logic. I think you remind the table of OR logic gate. Yes. Okay. In the first row, you can see it is addition of 0 and 0. It means it is 0 plus 0. 0 plus 0 is again 0, and the whole bar of 0 or the bar of 0 complement to 0 is 1. In the next row, it is 0 plus 1. 0 plus 1 is 1, and the complement of 1 is 0. That's why the output is 0. Okay. And the third row, X is equals to 1 and Y equals to 0. So it means the addition of 1 plus 0 is again 1, and the complement to this is 0. That's why the output is 0. In the last row, you can see 1 plus 1. Yes, 1 plus 1 will be 1 because it is high plus high logic, not it is 1 in decimal or 1 in binary. In the decimal, you can say 1 plus 1 is equals to 2, and in the binary, you can say 1 plus 1 is 1, 0. But in the Boolean algebra, it is high logic plus high logic is equals to high logic. That's why the complement of high logic is 0. And the expression for this, you can see on the screen, Z equals to X plus Y whole bar. Yes, the NAND gate and NOR gate are the combination of AND plus NOT and OR plus NOT. But these logic gates are called as universal logic gate. What is the meaning of universal logic gate? Is you can realize any logic gate with the help of only NAND gate or only NOR gate. It means if you have in your library or in your lab only NAND gate, you can realize or you can make any of logic. Either it may be NOT, AND, or etc. Any logic you can make only with the help of NAND logic, or the same as for NOT logic. NOT logic is also a universal logic gate. Okay, we will realize all the logic circuits with the help of these universal logic gates. Okay, the next logic gate is Xor logic gate. It is the full form. Maybe some of the books are considering XOR or exclusively OR. Exclusively OR. Why it is exclusively OR? We will see in the truth table. This is, as you can see, this is the expression, or this is the symbol for the XOR logic. Okay, it is little bit similar to the OR logic, but it has a another symbol. It has a another curved line which represent the exclusively OR. Yes, in the truth table, we are considering here only two inputs. We can have the inputs 2, 3, 4, or n number of inputs and y as the output in this circuit only. Okay. If we have two input, it means we have four combinations. Four combinations are, as we know, 0, 0, 0, 1, 1, 0, and 1, 1. Okay. What is the working? We can see with the help of truth table. If we have 0, 0 as input, the output will be 0. If we have 0, 1 in input, the output will be 1. If we have 1, 0 at the input end, the output will be 1. And if we have 1 and 1 as input, output will be 0. Okay. I think you can see if we have similar inputs. Similar inputs means both the input have same values, like first row and fourth row. In the first row, you have 0 and 0. And the last row, you have 1 and 1. If you have same input, either it may be a 0, 0 or 1, 1, the output will be 0. If you have different input, either it may be 0, 1 or 1, 0, both are different, then output will be 1. Okay, from here we can conclude the circuit or the logic gate. Output will be 0 for similar inputs or the same input, and output will be 1 for different input at the input port. It is for two inputs. In the three inputs, we will see in the Boolean algebra. Okay, the symbol is this, and the expression, output expression or output is equals to a b bar plus a bar b. From here, to remind this expression, we can see one of the term or one of the input will be complemented. Suppose we have two input a and b. It means first time the b bar with the a and ORing with the a bar with b. Okay, it is the exclusively OR. Why it is exclusive OR? Because you can see that if you have 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 in the normally OR gate, we have 1 plus 1 is 1, but it is exclusively OR. It means you have different input to make output 1. Okay. The next logic gate or the last logic gate is XNOR. XNOR, as the name implies, it is just complement to the XOR gate. XOR gate, in the last slide we have seen this XOR gate, the output is 0, 1, 1, 0 for the combination of 0, 0, 0, 1, 1, 0 and 1, 1. Yes, it is the symbol and it is the truth table for the XNOR logic gate. If we have A and B to our input and Y as output, this is the symbol for the XNOR logic gate. It is just complemented to the XOR logic. Okay. From the truth table, we can see the working of XNOR logic. If we have 0, 0 in the input of XNOR logic, the output will be 1. If we have 0 and 1 at input port, the output will be 0. If we have 1 and 0, the output will be 0. And if we have 1 and 1 at input port, the output will be 1. You can see it is just complement to the last logic gate, that was XOR logic. Yes, from here you can see, or you can say that it is for the XNOR logic gate. You can say that if you have same input, or number of inputs at the same input, output will be 1. If you have different input, or you can say combination of 0 and 1 and 1 and 0, the output will be 0. But as you can see, it is just opposite to the last one, or the last is XOR logic gate. Okay, the expression for the logic gate is y equals to AB plus A bar B bar. To remind the expression, you can remember like ending of the normal terms or normal literals or normal variables A and B, and ORing with the complemented term. Now this time it is A bar dot B bar, not A dot B whole bar. Okay, I think you have understand all the logic gates. We have 7 logic gate. I just remind you, not logic gate, and logic gate, or logic gate. These 3 are basic logic gates, and the 2 universal logic gates, that are Nand gate and NOR gate, and there are 2 exclusive gates, XOR gate and XNOR gate. It is all about the logic gates. We will start Boolean algebra in the next lecture. Okay, thank you, students.